So, what if the entire universe is structured like a giant brain? Now, I know that sounds like a wild thought experiment, but today we're going to unpack a new scientific theory that suggests it might just be reality, connecting the grand scale of the cosmos to, believe it or not, the inner workings of our own minds.
I mean, that sounds like something straight out of science fiction, doesn't it? But it is the absolute central question of a brand new scientific paper. And the theory proposes that the answer is a shocking yes. That our universe isn't just some random splash of galaxies, but a massive information processing network.
And this just gets right to the heart of it. On the left, you're seeing what the theory calls a QBH filament network. Think of it as the fundamental grid of spacetime. And on the right, well, that's a neural network from a brain. The resemblance is just uncanny, and according to this theory, it's absolutely no coincidence at all. And let's be clear, this isn't just some philosophical idea. It's grounded in a new paper by Daniel L. McGee. This quote really nails the core concept. What if the geometry of spacetime itself has the principles of information processing built right into its very fabric?
Okay, so how could this possibly work? Well, the theory, and it's a bit of a mouthful, is called the quantum black hole force cosmic expansion theory, or QBHFCE for short, and it proposes something truly radical, a fifth fundamental force of nature.
And this force is totally unlike anything else in physics. It isn't carried by particles we know. Instead, the theory says it's mediated by these things called quantum black holes, and it flows along invisible filaments in spacetime. But here's the most important part. Its strength isn't fixed. It actually evolves as the universe expands, which allows it to connect the impossibly small quantum world with the mind-bogglingly vast cosmos. All right, I know there's some math on this slide, but don't worry about all the symbols. Just focus on that little 1 plus z factor. In cosmology, z is redshift. It's basically a way to measure cosmic time. And what this little piece of math tells us is that this fifth force actually gets stronger as the universe gets older and expands. That could be why we've never noticed it until now. So, if we've got a new force, what kind of structure does it build? This brings us to the architecture of the cosmos, according to this theory. A vast, interconnected network. First, you gotta rethink what a black hole is. The theory talks about quantum black holes, or QBHs. So forget the idea of these giant cosmic vacuum cleaners. In this model, they're more like fundamental nodes, junctions or hubs in a massive universe-spanning web. And this schematic, which is right out of the paper, gives us a little glimpse of that structure. Each of those dots represents a quantum black hole, a node, and the lines connecting them, those are the space-time filaments that carry this new force. So this isn't a map of where the galaxies are. The theory suggests this is the underlying fabric of space-time itself. Okay, so we have the nodes and we have the filaments. Now let's bring it back to where we started. With this physical framework in place, that whole analogy to the human brain starts to look a lot more concrete and a lot more powerful. And this table, wow, it just lays the parallels bare. The QBH filament network is like the brain's connectome, its complete wiring diagram. The fifth force acts a bit like our neurotransmitters, carrying the signals. And massive cosmic structures, like the Great Attractor, are compared to neural clusters in the brain. But here's the wildest part. The universe's expansion is seen as a form of neuroplasticity, the brain's ability to learn and rewire itself. I mean, the parallels are just stunning. Now, this all sounds absolutely incredible, but for a theory to be actual science, it has to be testable. It has to make predictions that we can go out and check. So the really crucial part is, what does the QBHFCE theory actually predict? The very first prediction takes us from that huge cosmic scale all the way down to the microscopic. It suggests that if we just look closely enough, we'll find that gravity doesn't behave exactly the way we expect it to. So the theory actually proposes a tweak to Newton's classic law of gravity. It adds that extra bit you see on the right. That's the signature of this new fifth force. Now, it's an incredibly tiny correction, and because of how the math works, its effect just vanishes over long distances. That's why we would only be able to detect it when we measure gravity at really, really tiny scales. So how tiny are we talking? Well, the theory predicts a deviation greater than 1 part in 100,000 at a distance of about 100 micrometers. That is right on the edge of what our most sensitive experiments can detect today. Finding this would be a smoking gun. The second prediction looks up to the heavens.
at some of the densest, most extreme objects in the entire universe, neutron stars. This new force should change their fundamental properties. And this is just fascinating. The blue line you see, that's what our standard physics predicts for neutron stars. But the QBHFC theory, that's the red line, suggests this new fifth force acts as an extra support, pushing back against gravity's crush. And the bottom line? It means neutron stars could get much, much more massive than we currently think is possible before they collapse into a black hole. Specifically, the theory predicts a new maximum mass of 2.6 times the mass of our Sun. Now, our current estimates are closer to 2.3. So if astronomers find a neutron star heavier than that, it would be incredibly powerful evidence for this new physics. All right, the final prediction takes us into the world of particle physics and to the most powerful machine humans have ever built, the Large Hadron Collider. When we smash particles together in the LHC, the theory predicts this fifth force will create a very unique signature, missing energy. What that means is that new, invisible particles related to this force would just fly out of the collision totally undetected, carrying energy with them. But physicists can look for the specific energy footprint they leave behind, which is what this equation here is describing. And here's the real kicker. The theory predicts that these specific missing energy events should happen over 5 times more often than our current rulebook for physics, the standard model, would suggest. That's not a subtle hint. That is a giant flashing sign telling us that something entirely new is going on. Which brings us right back to the ultimate question this whole theory forces us to ask. If the universe truly is a giant interconnected network, kind of like a brain, then what is it thinking about? What information is being passed along all those cosmic filaments? This theory might not have all the answers, but it gives us a stunning and, most importantly, a testable new way to look at everything.